by the end of today's lessons, you guys will have learned how to take the derivatives of what's called the exponential function. And the exponential function is basically the function f of x equals e to the x. But before I really get into that much, I do want to talk about one particular property of the exponential function. And that property is sort of like what happens, how can we simplify e to the natural log of x. And this is something you guys should have seen before, but I just kind of want to show it to you now and make sure we're clear on this. And it turns out this is x, right? So for instance, I mean, I can do another one of those, right? What if I had e to the natural log of x squared minus 3? Well, this would be x squared minus 3. The concept is that people like to think this idea that like the e cancels with the natural log and you're just left with whatever's inside, right? So if you had e to the natural log of 2x minus a, this would be 2x minus a. And the reason I'm covering this is that if our goal for today is to be able to take the derivative of e to the x, it would be really nice to know when some of these will simplify into really, really nice, easy things. In fact, I mean, there's a sense in which I could sort of give you a funny question right now, which is find f prime of x if f of x is e to the natural log x cubed. And on the one hand, you're looking at this going like, man, I have no idea how to take the derivative of e to the natural, oh god, this is terrible. But think about what we've done for the past couple of days. We've done all of this like simplifying of logarithms first. You could start this problem by saying, well, I know that f of x is e to the natural log x cubed, like that was just given to us. So I'm not taking the derivative, I'm just rewriting the problem. According to what I just said about this property of the exponential function, how can you rewrite this thing? Well, that's apparently exactly the same thing as x cubed, which means that f prime of x, the derivative of that, will simply be 3x squared, and you're done. There are some problems in the homework that are like that tonight, where the entire purpose is that I expect you to recognize that this can be simplified into something really simple that we really just already know the derivative of. So heads up for that. One bit of warning about that. It only works when you have e raised to a natural log and there's like nothing in front, like there's no number in front of the natural log and there's nothing being added on the end of the natural log. So for instance, what if I asked us to simplify, like let's say e to the 2 natural log of x, right? Some people will mistakenly, put it in red because it's wrong, some people will mistakenly, say, well, if I have e to the 2 natural log x, I could just cancel the e with a natural log, and I get 2x. Yay! Again, totally wrong. The correct way to do this problem is to recognize, okay, so I have e to the 2 ln x. I can take that 2 power and move it up, like using the properties of the natural log. This would be e to the natural log of x squared. And now I'll agree with you, the e and the natural log are effectively inverses of one another, and so what I'm left with is just the x squared. Right? So when you see problems in the homework tonight, if you see something that has e to a natural log, understand that can be simplified. And you always, like in almost all cases in calculus, if there's a way to simplify something before you do the problem, you should simplify it, because you're going to make the whole thing a lot less complicated for yourself. So that's the end of this video about simplifying. Now we're going to go and just get straight into to all of this business of taking the derivatives and integrals of this exponential function.